Hi, my name's Kevin Smith. Today I'm going to be giving a presentation on MQTT Communications 101 and how it works. So intro, I'm going to start with the intro to ELPRO, show its product deployments, go over an IIoT model showing hardware, the communications, which is MQTT, and then also connectivity to a cloud-based server in the IT space of the model. Then I will go over the product portfolio using this communications and end with a benchmark communication scenarios that compares to MQTT to other communication protocols. So ELPRO has been in business for over 40 years, providing innovative wireless solutions around the world and has about 500,000 units installed. I live outside of New Orleans in Metairie, Louisiana, of the U.S., and my coworker Matt is out of Tampa, and we both cover the Americas. So, as in deployments, we are in a water wastewater. We do have a protocol, products that communicate a protocol called Alert 2. It's more geared for monitoring and just reading in information from disaster applications. We do get into power to monitoring tank levels in farms where it could be one tank or a farm of tanks. We do get into oil and gas monitoring, well monitoring, vibration, whatever system they have in a petrochemical plant. We do have Class 1 Div 2, so where it can be mounted, be used in that industry. So here's an IoT model. It is industrial Internet of Things, to where on the OT side, the operational technology, that's where you're pulling in all the information via communications to a PLC or directly connected to a sensor, communicating that up to the cloud, as everybody calls it, which is the IT area of the model called information technology. In between there, they have the transport layer where it's using MQTT, in this case, to go over a cellular connection via an edge device or through what we're calling fog devices that will collect the information locally to the OT area of the model and then through the edge to the IT area of the model. So what ELPRO offers is the hardware to transport that information, the information from the OT part of the model to the IT, which would be within the edge or the fog. So our products are considered the edge on network nodes, where we have two options for cellular, one that is an IoT gateway and another one that is a pass-through. And then on the fog, as it's called, we have multiple devices that communicate Wi-Fi, unlicensed 900, and licensed frequencies, and also a hardwired connection via Ethernet. So conventionally, in plants, you would have sensors being wired to PLCs, communicating over an OPC connection to HMIs, which then goes through a firewall or a gateway or a VPN for protection for security to the cloud or on-premise device. The latest solution would use MQTT, which it would be collecting the information from those PLCs or sensors directly into a controller or gateway, then built into the gateway's configuration, able to add security to have a secure connection to the cloud using TLS certificates. So the communications, as I mentioned, is called MQTT, which is at that edge of the communications. So what it is, it's a very lightweight communication protocol that publishes information, writes it, and then subscribes to clients. So the clients would ask to receive that information and read it. So it's very lightweight. It has encryption from that TLS security or certificates. It can be mounted on a local broker or configured on a local broker to pass the information between nodes. And then also it can also be communicated through a remote broker up in the cloud. It has a secured login, so it has a URL or an IP address that it needs to know to communicate to and from. It has a username and password, and as I mentioned, it has additional security using TLS certificates. So, how it works is it has what is called a keep alive ping connection that allows the end devices or the nodes to connect to the broker. And then, as long as this connection in ping is available, it allows each one of the clients to know that it has live data, not stale data. So, how it would work, you would have these nodes communicating via the broker, and then the clients or subscribers connecting to the broker to collect that information. But if that ping ever or the keep alive breaks, it will let you know and let you know that you have stale data. So, in comparison to Modbus, it's a more inefficient whole network to where it goes out to each one of the nodes, asks for the data 3 times, and then if it doesn't see that data communications, then it'll throw a flag and give you an error. It's very inefficient and it does not have any security to encrypt that data. On the other hand, in comparison to the MQTT broker, it does. It uses a publish subscriber model that's bidirectional, and it only sends its data when it changes. So it's very, very efficient. You can add those certificates to add that security, but then if you want more advanced security, then you can set it up in a DMZ zone or segment it using port forwarding. So on the low administration as an advantage over other communications, MQTT allows, as I mentioned, to just report its information when it changes. It also has that data integrity to where if it does make a connection via the keep alive mechanism, it'll create a birth certificate. So it sent all of its data to the broker for the clients to see. But then if that keep alive connection or ping gets disrupted, it will send out a death certificate to let the clients know that the data is stale. It also has a unified namespace, which means when you're programming it in the standard format, the difference between it and the Sparkplug-B standard, engineering firms and system integrators can set up the data in different ways unless you have a specification set in that. So from install 1 to install 2, your data might be different. But what Sparkplug-B does, it makes it to where it's a standard format, so where you can see the data in that standard format and not have to rely on a specification and coordinate that with the engineering firms or system integrators. What I like is within the node ID, if you don't give it a name, it actually uses the serial number to where you can identify what node it's actually communicating to. Up in the cloud, as it considered the IT, that's where Ignition or VT SCADA would reside. It has a driver built into it to communicate MQTT, where other manufacturers may not have that protocol built into it. But they're software companies, they develop it to where you can. And the advantage of that is what I just mentioned with the namespace, and then be able to have that keep a live connection to where you have the stale data. Another feature that it has is a store forward information. So at the edge, you can have, for example, with the ignition edge, a subset of a graphic communicating to a server in a cloud. Our devices have this feature to where you can store the data locally, and then when you lose that connection and it reestablishes it, it will forward that information and backfill the information in the HMI. So, especially when you're doing data logging and historical trending, you, this is a very good feature. It's similar to the way that DNP3 does it. So, as I mentioned with Ignition, it uses that edge on the edge of the network to provide you with an HMI. Up in a cloud, it exchanges all of its information with that store and forward mechanism, and then it uses for the transport of the data an MQTT engine. So to summarize with the IIoT model, there's four different configurations where one, if you're in the fog, you can collect the information locally and then just send that information to the nodes other than up in the cloud. The second way is that same functionality, but then have a connection to pass the data to the cloud. Third is a direct connection from the cellular modem or the IoT gateway to the cloud. And then fourth is a combination of the three. So what we have to offer as products to in this edge and fog area is multiple ones to where you can use cellular with the 641M, which is an IoT gateway. The 645M is a cellular router or modem that just passes the data through it. In the fog area, we have Wi-Fi products. We can communicate also unlicensed 900, and we can also communicate license frequencies from 150 to 900. And then with the 415U1, we have an ultra low powered unit that interfaces to the 415U2 or E to pass that data through a cellular connection to the cloud. We also have with the 115E2 direct connection via Ethernet. So the rest of the presentation is showing more of a benchmark between MQTT and other communication protocols. Engineer, I browsed the web and looked for a third-party presentation that shows this. I found one which Jonathan Hotel from Kelvin Inc. has done, and he made a correlation between multiple communication protocols and the advantages of one to the other. So what he did is you have to find out really for your application how you're communicating. So if you're on the plant level or wired communications, OPC probably is the best protocol for that because you can send a lot of data and you can send it within microseconds. But when you get into a battery powered SCADA system, it's a little bit different when you're communicating over a cellular connection. So you need to have a much more efficient network to do that and just send the data when it changes so you can lower your data plan because when you communicate in cellular or satellite, you're paying for every piece of data that's being transmitted. The other part for this discussion, we need to discuss what is the difference between a data packet and data. A data packet is the full transmission of data, including the headers. So you need to know via the header where the data is going to and from. So that is with like the Ethernet, it's a little bit more of information. It's 20 bytes per header, where, like I mentioned with MQTT, it's a lightweight one, so where it can go and just use 2 bytes for each. The payload is what is referred to as data. So that's the part that the data is being transmitted in back and forth. So the three different scenarios is a single value compared to 9 values in the second scenario, and then in the third one, it's more of an application in the oil and gas field to where you're transmitting 389 tags. So with the first case, with one value, Jonathan compares OPC with HTTP, Modbus, and MQTT using that keep alive signal change set for 5 minutes. Its data changes twice a day. So the total cost of ownership of the data is 5 seconds of data per day. So when you compare the packets, a little bit more data, but look at how low the information is or data is for the MQTT compared to the others. And even lower because you're just breaking it out for the data to be 51. So the comparison of that and the reason for it is it's only sending its data when the data changes. So you have up to 95% or 99% efficiency in comparison from the MQTT to Modbus. The second scenario would be a little bit more information. It's showing the comparison between the different versions of MQTT. And when you compare it to the Sparkplug B, there's a feature built into it where it can actually compress the data by 3, which gives you even a more efficient network. So when you compare that to Modbus, it's 4 times more efficient, but then when you compare it to basic MQTT, it's 3. So in the third scenario would be that oil and gas application where you're retrieving 389 tags from a well site where 223 of them digital tags that would not change in an hour, 111 tags would change hourly, 19 intermittently used analog values, and then 36 analog values would change every minute. So if you combine all that together, it really the data is not changed. Almost 60% of the data does not change. So you see a huge difference in efficiency using MQTT Sparkplug B, to where it's about 10 times better than Modbus. So in summary, the bandwidth is much lower when you're just sending the data when it changes. It also improves it even more because you're compressing it by 3. So the results is a much efficient network, up to 99.5%. But if you're making comparison to your application, you have to look at everything individually because different data will change that efficiency. But even if you have, we just showed 3 scenarios, if you have more data and it's sending different variations of it, it's still going to show you very high efficiency. Any questions?